Today I'm going to show you how I built this shaker table. I'll take you through all of the steps and including the results at the end. I'll run some material through it. So it's a small portable unit. It's roughly 8 by 27 inches dimensions. It uses aluminum flexures to support the table, which I'll describe in detail how I made. It has leveling adjustments to easily level it in the field. It has two output ports. One is for gold and the other is for heavy sulfides. And the tailings run down this trough and into this bucket, which you then dump later on. And I'll put this SketchUp drawing in the description below in the video so that you can have it. And if you don't know SketchUp, it's really quite an easy program to use. For instance, you can measure dimensions, kind of like that. You can make modifications to the drawing as you see fit. You can hide objects and unhide them and so forth. I've cut out some strips of hardwood that are going to go around the edge of the piece, and I'm just going to glue that directly. I'm going to glue the hardwood directly to the platform. And I've left it a tiny bit oversized so that I can trim the sides on the table saw. And I've also glued these 1/8 inch pieces of plywood as steps onto the 1/2 inch piece. Okay, I've cut another piece of 1/2 inch plywood. This is the top of the drive stage, the motion stage. Now I'm going to assemble the two ports where the heavy stuff comes out. So I drilled a 1-inch diameter hole, and this is 3/4 inch PVC pipe. And then you have to open that up a little bit because the nominal OD of this is 50 thou larger. So I used this on a drill, opened it up, and now I have two ports like that. This will get epoxied. Now I need to glue this, which is my two ports, and this is the top of the table at the output end. All right, here I've made the pieces for the tailings tray, and I've shaped the ends, mitered the end a little bit so that it fits correctly with this piece. I'm going to glue the tailings tray onto the table. All right, I got the tray glued on, tailings tray, and there's a little bit of discontinuity between this piece and these steps. So I'm going to take this beautiful tool called a Shinto file, and I'm going to smooth all of that out, here, there, etc. just by slowly taking material off. I've made the side piece. This is the front of the table and the side of the front. All right, we got the outside of the tray here on. Okay, now all the sides are on, everything's in place. The last thing to do is to put on these end pieces, which I've already cut out. Here's the nearly finished tabletop. I need to add some 45-degree thingies in here to help the material flow into the hole. The water bar needs a support over here and one here to lock it into place. Here are the wedges for the ports, and just throw a little bit of glue on there. And stick them in. I made all of the stuff to hold the water bar. So here's the central support. A knob goes in there to capture the bar. And then on this end, there's the recess that holds the end of the bar. At the moment, these corners are only glued. And I found that's not such a good thing. So I'm using these nails which have the gripping thingies in them, and they work really well. So I'll put 2 or 3 in every one of the corners, and the way I do that is I drill it first, otherwise you risk splitting everything. So I'll put it drill hole through there, and the nail is quite a bit bigger than the drill, so it still grips really well. What I'm doing now is I'm applying, the camera's kind of in the way, but applying JB Weld epoxy with my finger. And I'm putting a fillet in every one of the corners of the 2 ports. I'm going to cut the slot for the flexure support in this piece of 1-inch wide hardwood, and come down like that. And to do that, I've set this blade. This is a 1/16 inch kerf saw blade. I think it's what, 7 1/4 inches in diameter, and I've used a gauge to set it to 18 degrees. I've got what I need in front of me to make the flexures. These are the strips of aluminum, which are the actual flexures themselves. And I've taken some 80 grit sandpaper and I've roughed up the surface so that the glue will hold. Here are the flexure supports, and I use JB Weld, and I'll let it cure for a day. All right, there's the finished glued up flexure, and I've marked out a 3-to-1 slope, and you can see this is 3 units by 1 unit. It's actually 200 millimeters and 67 millimeters, and it's crucially important that the table move the gold in the right direction. So here's the motion of the gold. That means that the flexure has to be in this orientation, which is like that. Okay, now back over to the flexure. You can see how I've got it clamped to the top of the motion stage. And when this dries, I'll turn it around and do the other flexure. This is the base. There's 2 pieces to the base. This gets bolted to something. And this base is adjustable. And I've put threaded, 1/4 threaded inserts in 3 places. And that's for leveling adjustment. And there are 3 more holes for locking it down. So it's a push-pull kind of a system for leveling. So I got all of that, all of those features I put into this. I've drawn the location of the feet for the flexures. And it goes right there. Then I made a motor mount, pretty simple, an obvious motor mount for the motor. And just an aluminum plate screwed with really long screws, about that long, into a piece of hardwood. I've added the mount for the shaft. This is a 8mm shaft, and that's because the motor is also an 8mm shaft, so I just stick with 8mm shafts everywhere. And I have some 8mm bearings. They're super common because they're used on skateboards and stuff. Okay, so this is now attached, and I believe, I'm going to think about it for a second, but I think that's ready to glue down. Okay, I got a couple of lead weights on here. That just provides some clamping force. We'll let the glue dry, and then I'll put some screws through all of the feet of the flexure. So this morning I'm going to make the arm that connects the motor to the pin on the top of the table. This is the thing that pushes the table, shakes it. And I've been under the machine and I've measured the center to center distance that I need between these bearings that I'm going to put in here. And that center to center distance is 222 millimeters. So I've cut a piece of hardwood, and I'm going to first take off about a little bit less than 1/4 of an inch, so that I have two pieces, and this piece will hold the bearings in place. This isn't the easiest even or the best way of doing it, but it's what I have to work with in the shop. I mean, most people would probably press fit this bearing into a steel arm or something like that. Anyway, it's what I've got. So I'm going to go to the table saw and I'm going to cut off a strip. Okay, so I've got these two pieces screwed together, and now I'll put the bearing cavities in the ends. The cavity I need in there is 7/8, and that's what this Forstner bit is. So I'll go right into there, and I'll go the depth of the bearing. The two bearings are in their cavities and they're right flush with the surface. Now I've got to put a clearance hole for the shaft here and here, and of course there and there. And there's the finished arm. Pretty simple. It's probably 20 minutes of work. I have a piece of Delrin here, and it's 1.3 by 1.5, and it's 0.75 inches thick. This is going to be the eccentric coupler. So in the end, I'm going to split this down and offset it, and have a shaft here and a shaft here that are offset. And I want the offset to be 1/4 of an inch. I found that that works very well for these tables. So the first thing I'm going to do is to drill an 8mm hole with an 8mm brad point bit. I'm going to drill it all the way through this block. Now I'm going to scribe a line right down the center of this. That's going to be useful later when I cut the two pieces apart. I'll be able to use that line to determine exactly how much offset I have. So that's the center line. Now I'm going to set the calipers for that distance minus a 1/4 of an inch, and I'll do that off camera. So now I have 2 lines, and they're separated by exactly a 1/4 of an inch. So there's the holes for the retention screws. They've been drilled and tapped. So there's the cut, and of course I'm going to offset it like that. And I'm going to temporarily glue it together like that with super glue, because I need to drill a pair of holes and put a screw through there to keep these 2 pieces firmly together. And there's the finished up eccentric mechanism. So the shafts are retained with these. There's 2 of them somewhere. And the Delrin has this, that's not the right screw. Anyway, we'll find the right screw. The Delrin has a nice property of kind of locking the threads here too in this screw. I've cut an 8mm diameter shaft, more than long enough, and that goes into here. Alright, so let's take a look at where we're at. I have the motor mounted. I have this shaft couples to the top of the table. It's not glued into place yet. And the eccentric mechanism is on there. And now the coupling arm that goes from there to there I'll put on, and we'll make the table go around or shake. All right, so let's race some pennies down the table. Cut a piece of neoprene rubber sheet, 1/4 of an inch thick, and I've rounded this edge over a bit. This is where the water flows down and over, and I'll round out that edge a bit. But right now I've got 220 grit, and I'm just taking the shine off the rubber. So this is the layout for this table. Yeah, so where to start? There are 2 steps in the table. One is there and the other one is there. And of course this is the loading zone. The material flow, the shaking action is in this way. The material flows down here, and the shaking action drives the material this way. So you can see kind of the idea here is I'm only using the part of the table that actually does any real work. Most shaker tables are larger, you know, they're bigger in this direction, but the gold and the heavy material, the real heavy stuff, it never makes it down to here. It's always transported that way. So I've just eliminated all of the table that actually doesn't do much of anything, as far as I can see. So anyway, that's the idea. The proof is in the pudding. These lines are separated by 10 millimeters. The grooves, these will become grooves, and the width of the groove is determined by the bit on the trim router, and that's 5 millimeters. So there's 5 millimeters of groove and 5 millimeters of no groove. Now, since there's a step in the table, I want to drive all of the gang material, the lighter stuff, the quartz and the clay and junk, whatever, down here and not let it go farther there. So I've stopped the grooves there. And then transporting grooves past this step, or the first one, which is where most of the gold is going to go. The second one, a little bit of the gold goes there, and almost nothing goes down here. So these are kind of there just to catch the stuff that doesn't get caught up here, and it's only, I think, a few percent. Okay, so that's the basic idea. I'm going to cut that pattern and we'll see how it works. Here's how the grooves get cut. There's a collar around here which acts as a guide, and that guide goes into this groove, and I've set the depth of the router so that the bit is protruding about 2 millimeters, which I find is works really well. Now, the end of the groove has to have a gentle rise to it so that there's no place where the gold or the other heavy materials can get caught at the end. And to do that, I've built a ramp into this, whatever you call it, guide. So I built a ramp into the guide so that the router just comes up gracefully and stops cutting. And you'll see that when I cut the groove, you'll see how that, I call it the launch. It kind of launches the gold back onto the table in a smooth way. And perhaps you can see what I've done there. Okay, so that's really the whole setup. I then kind of mark this guide at where the start and stop of the grooves go. So for instance, if I were going to cut this groove, which I will, the end of the cut goes right here, because that's where the cut would end with that slope. Okay, so you know, you can experiment with that and determine it once. And then this one goes off the end of the rubber, so I just cut it all the way, and you'll see that right now. Okay, I've lined up the guide. Here's the end of the groove there. There's the line that denotes where that will end, where the groove will end as the tool comes up. And then I'm going to go all the way, and there's a couple of lead weights that hold this down, although this stuff is has a very high stiction, and you know, the guide is going to stay there probably with or without these things. So I'll try to leave the camera in that location, and I'll make the cut. So now I use a piece of 150 sandpaper, and then that's what I use to clean up the grooves. And it requires a little bit of patience, but it definitely works. And here's the 220. Some final cleanup, including the launch. And that's a finished groove, I think. More or less. I've finished cutting as many grooves as I'm going to cut right now. I leave, turn the camera a little bit. I'm going to leave this end alone because I want to watch what happens to the gold. And so what I do is I drill holes for brass pins, and then I epoxy the brass pin into here, and that keeps it waterproof and so forth. So I'll do that right now, and I do it with this in place, because then it'll be perfectly aligned to the table. And if I want to make another mat, then I just use those holes in this mat to make the holes in the next mat, so on. All right, now I've got a pin there, and I've got a pin over here, and that holds the mat perfectly. Now I'm going to make the water bar. I'm going to actually just drill the holes in the water bar, and at first they're going to be spaced just 1 inch apart, except of course where this holder is, and I'll make sure that I don't drill a hole so that the water can't come out. And the water bar goes in here like this. And this knob tightens down and holds the bar very firmly in place. Okay, here you can see the whole water bar. I've drilled holes. I've maintained the same average spacing here. I just, moved them out a little bit. Number 22 drill is 156 thou. This is the adjustment mechanism. So to adjust the slope, I unlock these two, and then this adjusts the slope of the table up and down. This is the kind of the front of the table. Once I've adjusted the tilt, the slope this way, then I can lock those two. And this is the back of the table, similar plan. I unlock this, and then I can adjust the side-to-side tilt of the table using these two knobs, and when I'm finished, I just lock it down. It's kind of a classic push-pull system. All right, here's the first test of the table, and no, you're not going to get wet. So the first step in the table is right here. That does a nice job of rejecting the lighter material. And then the second step of the table is here, and that rejects a lot of the sulfides. And then this groove is used to catch the sulfides along with this one. And these two grooves catch the gold and the really difficult sulfides to remove. So let's turn it on and see what it does. So here I'm going to weigh out, I don't know, 200 milligrams. Of fairly fine gold. $200 milligrams. here's what came out of the number 1 port, the cons port. That's where all the gold should be, hopefully. And I'll pan it out. So it's just the finest, blackest sand you can imagine. This came from the beach here in Los Angeles after a winter storm. And the beach was full of it. Well, that's what I got. It's still not perfectly clean, but I'm starting to lose quite a bit of the ultra fine stuff, which means that the table actually, you know, picked up the ultra fine stuff, so that's a good sign. Okay, so here's the gold that came out of the number 1 port. We started with 200 milligrams. This is 160 milligrams, so that's 80% recovery. So here's what came out of the number 2 port. I'm guessing that's at least 10 milligrams, maybe a bit more. So a total of, that would make it like 85% recovery rate. And of that, 80% goes in the number 1 port. Well, that was a long video, huh? Thanks for watching to the end. I had the machine in the desert a couple of weekends ago, and I ran a bunch of material through it, and it was a lot of fun. I mean, it's a great little machine. However, a couple of issues, I think. The loading zone of this thing is just too small. I would like the loading zone, which maybe is like this area here, I would like it to be twice as big. You can't run very much material through it, which kind of slows things down, even when just prospecting. So I'd make it bigger for sure. The other one that I built, the first one I built, which I've have a video of the operation of, is much more favorable. So I would go back to, this is only 8 inches wide, I would go back to at least 12, maybe even 16, and I would certainly make it 3 feet long, the table part. Other than that, it's a blast. I enjoyed it. So thanks for sticking around till the end, and good luck if you try to build one. They're fun.